A transition zone can be optimized to generate similar loads as the nominal track, and that's what we could see from the non-dominated fronts that I've shown you, where we compared with the black lines, which were the loads far away from the transition zone. And this in particular now where we look at the straight track with no irregularities.
Dr. Xiao.
We found the high frequency excitation of real wire force generated by the plug-in wire or real corruption. If the frequency is close to the natural frequency of clip, which may lead to the clip damage.
Okay, Dr. Yan.
In some dynamic tests, we found some interesting phenomenon. One is why the test results in field test is not one fixed frequency. So we found some method to solution how and why, and finally we found that the Doppler effect is important and influence on the dynamic test, especially in the high-speed railway lines. So.
Okay, thank you everyone. Now, the audience, please attack our defenders.
Thanks very much for all the presenters. May I ask one question to Emil? That, I'm not sure can we go to your presentation, but you've showed one slide with the wheel load, contact force.
Yes.
And if I remember correct, that from ballast to slab track, there is no amplification on the ballast part of your simulation result.
Well, since we have the stiffness gradient,
yeah.
If we go from ballast...
I mean from the normal...
for the nominal track?
Yeah, for the nominal track.
Yeah, if you go from slab track to ballast track,
yeah.
then the wheel rate contact force will be increased as soon as you get to the ballast track. As soon as you change track, you change the stiffness of the track, then you will get increased wheel rail contact forces.
Yeah, that's my question. That if a train travels from a ballast to a slab track and the wheel load only amplified on the slab track instead of the ballast track, so the ballast track will never settle. Is that right?
The ballast track will never settle.
Yeah, because there's no amplification of wheel load on ballast track.
Is it possible to get the slides back? Because there is a significant reduction, increase of the wheel rate contact force as soon as you go to another track, when you change the stiffness.
I did see the amplification on the slab track, but not on the ballast track.
Is it possible to get slide 11? Or slide 10, I think.
I think, slide 10, I think.
But maybe we can discuss afterwards if it's problematic here.
Yeah.
But
of course.
Please start the first presentation to page 10. Maybe it's easier with the figures.
I can see my presentation on this screen, but it's a bit hard for you.
Okay.
It's here.
I can pretend that I see
I can turn the screen for you.
No, it's there. Page 10.
Let's see.
Yeah, this one. So if we see the left figure, so that is ballast to slab track.
Yes.
And if we only focus on the right part, which is ballast track, and I couldn't see any amplification of the wheel rail contact force. So if there is no amplification of the contact force, that means the ballast track will never settle.
Well, what you refer to settle is it's not necessarily an increased wheel rate contact force that will give settlement. I mean, it's usually the pressure on the foundation which is correlated to the amount of settlement you get. But there are usually empirical models to account for the amount of settlement that you will get. And if you look at the pressures on the foundation, it is usually a much higher pressure for the ballast track since it is a much smaller area.
But if the contact force is not increased, why the pressure is increased?
So the pressure is not increased. It's almost constant here for the ballast track.
Yeah.
But it's still larger than compared to the slab track because you're on a ballast track with the small sleepers. I mean,
normally, from our measurement results, we found the ballast track, well, the closer the zone close to the slab track, there is always settles more than the ballast like further from the bridge. That is our measurement result.
Okay, so you argue that you are getting settlement here, but
Yeah.
you're not getting settlement here.
Exactly. That's what we found.
Okay.
And yeah, so if the pressure is not increased in that zone, that can't explain the results that we found. There is extra settlement there.
No, then my study would not explain. Well, my study is not explaining why you will get settlement here and not settlement here, since we're getting the same amount of pressure.
I think that's a good point. Maybe you can discuss
we can
later.
continue.
And,
Yeah, sure, of course.
maybe
Thanks.
to raise some new further simulations and to give explanation later on. Okay. Yeah. Further questions? Yeah, please.
Thanks for the nice presentations. I want to ask a question to the both Chinese speakers about the formulation of the polygon wheels, and we find out that there is, in this case, the train has polygon wheels on the last wagon and even on the last wheel set. Is that just a random case, or is there some relationships to the position of the polygon wheels? Because we do not have everywhere in the trains the polygon wheels, but only on certain locations.
The test is for test train, so from first car to the seventh car, the wear is normal, and the eighth car, the wear is polygon. So
It's the test train. So
test train.
You just do it obviously to
yes.
to generate the test results.
Yes.
But so, is there any correlation from your field test results of where on the trains are those polygon wheels detected? Where on?
There are two dynamic tests, and the one is the polygon wheel is the test train, but the real corrugation is the operation train.
Another not same line.
It's clear. If I understand correctly, so the polygonized wheel actually was installed onto the eighth coach, right?
Yes.
It's not occurred naturally there.
Yeah.
Okay.
Oh, yes.
Yeah, that's only for purpose of the test.
That you want to do it on the eighth coach, or you just select this coach randomly?
Because it's the easier to change the test wheels, so I chose the 8th car, so it's not other trains cars.
Because from my point of view, at least for the lateral side, the boundary conditions for the first and end wagons are different from the middle wagons. So the vibration of the end wagons is always higher than the other, and so
yes,
that is,
but but I have compared with the first and the last cars. Yes, so it's the first compare with the first car with the other 2 to 7th car. It's normally same, but because the tester will set on the last wagon, so the last wheel set the test result is more bigger than others.
Okay, thanks.
Okay, next question. Yeah, please, there.
Okay.
You got iPhone? No. Yeah. Good.
Okay. Thank you. Good presentation. I have a question for first speaker, Mr. Emily. You use the optimization method NSGA2. So why did you select this method?
So you can use like classical optimization strategies that are typically deterministic, or you can use this stochastic optimization procedure that I use now. And the reason that a stochastic optimization procedure usually outperforms the deterministic ones is that the stochastic one can find the entire non-dominated front in one single run, and you can also use several objective functions. And the reason that I chose NHDA2 is that it is a very famous and very well-known algorithm to work good. So I have not considered other stochastic algorithms than that one.
Thank you very much.
So you choose this method because it's famous?
It is very well known. It has been applicable to a lot of different contexts, and it usually works well.
What's its advantage of this method?
Compared to other multi-objective optimization
Yeah.
methods, that I have not
Okay.
I have not studied other techniques, so
Okay.
I'm afraid I can't
Thank you
answer
very
that.
much. Next question, please.
One question for Dr. Xiao and Dr. Yan. In China, what countermeasures are put forward for clip damage?
Sorry.
How to solve the problem of
Solve the problem.
clip damage?
You know,
We can change the frequency, natural frequency of clip, the third one, and the effect measures to for grinding. If there are real congregation with grinding terminate.
This contains maybe is our next steps research. Now we have found this mechanism of the free damage. So next step we'll find out how we do to solve these problems. So maybe next time on the next CM maybe will show.
Are there any preventive countermeasures at this moment?
Mm-hmm.
Are there any preventive countermeasures at this moment?
Yes. Are there any problems? It's real grading and reprofiling of wheels to prevent this problem in our step.
Okay, thank you very much. And further questions? Yeah.
So I just have a follow-up question to the rim grinding. So do you have some studies on like how often or how regularly should we do the grinding for in case of prevention?
We based on our now research, we only control the grinding wheel depths, the depths, the wheel depths. So I don't how long it is to grading the wheels. I know the contents, but I'll give the control values or the depth or wheel length.
Because I think that this is kind of quite interesting for the maintenance, because we can then just find out when it is optimized time window. So for example, after how many train runs or how many tons of loading that we need to do the grinding in order that the polygonization or the corrugation is never happen again.
Yes, I very agree with you. It's very important.
So if I have the mic, so I would also like to continue the question to the Mr. Agustin. So because just now I have the second question for the study of the transition, because I think your study is on certain type of train with certain type of speed, and because do you think that this transition design is also so, or let me ask another way, how would you like to deal with if I have a mixed traffic track?
Yeah, so as you say, this transition has been optimized for one type of vehicle and one speed. What we have done is that we have done some robustness analysis and considered different speeds, and we have seen that also for other speeds, the optimized transition zone outperforms the nominal one. In particular for higher speeds, the loads on the nominal track is significantly increased, while the increases on the optimized track is quite small. And regarding other vehicles, we have not investigated that, but of course that could be extended in the model and take into account variation of vehicles.
Yes, because if you consider passenger trains or commuter trains to freight trains or whatever, their speed and are very differently, and the design of the wagons is also very different.
Yeah, indeed. The idea with this work is that it is used for high-speed railway lines, and then we have considered also high-speed train for the input data, but of course you can consider other.
So it might be that if you can go on further with the research to further on work out the algorithm, like how to deal with mixed traffic, like is there an optimized solution for all kinds of, or for other traffic situations, and so on.
Yeah, that could probably be extended, yes.
Thanks.
Okay, we leave some time for the other audience. Please, other questions? Anyone?
Can you continue my questions?
Yeah, please.
Mr. Yan. I think there are two types of the bending wave velocity. One is the phase velocity, and the other is the group velocity.
Oh, okay, I know.
Yeah.
Yeah, I know.
But you use the phase velocity, I think.
Yeah. In my view, the Doppler effect, how all of the frequencies in the whole frequencies, I think. But because there is no fixed frequencies in other frequency DOM, so I only find this Doppler effect, and so I chose only one fixed frequency and to verify that. So, but I think it's influenced all the frequency DOM. But I don't have pro that. I only pro the fixed frequency.
Okay, thank you.
Okay, we got 2 minutes more. Maybe the last question. Okay. Yeah, we have already a lot of discussions. If nobody raises your hands, and I would like to close this session. And thank you to all our speakers and the audience. Thank you very much for coming.